Hi class, this is number 2 in 8.2. For a confidence level of 80% with a sample size of 22, find the critical t-value. So we're going to be building confidence intervals here in this section. And one, idea behind the confidence interval is that we need to trap 80% of the samples. We need to know where we're going to cut off where 80% of those samples are located, in the middle 80%. And that'll be important for us because those are the most common occurring samples. And then the ones in the tails are going to be the ones out in the tails are going to be the ones less likely to occur. So, and for 80% confidence level, it means that we need to find this middle 80% of the data. And this is, I'm drawing it kind of like it's a normal distribution, but this is actually a t-distribution. It's a tiny bit different. And the only thing that's going to be different for us really is that we're going to be using a different, function, and we're not going to be using the normal CDF anymore when we're dealing with a t-distribution here. And they're using a t-distribution because we don't know the standard deviation of the population of our interest. And so we have to use a sample standard deviation, which causes the curve, our normal curve to be a little bit different, and it does change depending on sample size. So that's why they're giving you the sample size here, is because this t-distribution is going to change depending on that sample size. So that's the importance of giving you that. But our critical t-value is the t-value, and it's usually it's t alpha over 2. And what they mean by that is if this is the 80% confidence, if we have an 80% confidence level, then alpha is what we're not confident. So it's alpha is equal to 100% minus our confidence level. And we always have to actually write it as a decimal, but it's 100% minus the 80%. So it would just 20%. So what it's saying is that there has to be 20% of the data has to be split equally between this tail and this tail. If I want to cut off the middle 80% of the data, I have to split this between the two tails here. And so it's going to be 10% of the data, or 0.10 is going to be located here, and 0.10 is going to be located there. So that's why they call this the t alpha over 2 thing, because it was originally alpha was 20%, so 0.2, but then we divide it by 2 because half of it has to be on the left and half of it has to be on the right. So it becomes this t of 0.10, which is what, let me explain this, the notation here. It's saying the t-score, that means the number of sample standard deviations, if you will, such that you have 10% of the data to the right. So this is one of these problems where they give you the area under the curve and they're asking for the value along the x-axis. This is an inverse norm type of problem. You guys are so used to doing normal CDF, find the area under the curve, which is equal to probability. This one, they're giving you the area under the curve and they're asking for the this t-score along the x-axis. So to find it, it's really kind of simple. To find any t sub alpha value, you just have to do the inverse t instead of inverse norm, because it's a t distribution. I have to do inverse t distribution, and then you're going to input the area under the curve to the left. That's how these functions work, just like the inverse norm function, area under the curve to the left. So it's which it's going to be actually, because we have 0.10 to the right, it's going to be 1 minus that. It's always going to be, so the alpha is always the area to the right. So it's always going to be 1 minus alpha, and then you're going to put the number, the n. Then, and that's how we calculate. It's how we calculate any t alpha, any t sub some number. You just do inverse t of 1 minus that number, and then put your number in the sample in, and that's how you find a t value. So we need to find t 0.10. So we're going to do inverse t 1 minus 0.10. And then our sample size was 22. And then, so that's going to be our answer. And so that's the form. I believe you just do second vars, and then you can go to, you find the normal CDF function, but then if you keep scrolling down, you can find, usually find an inverse t function. And then, like I said, input the 1 minus 1.10 and then 22, and then find your answer. So that's how you do it if you did it on the TI-84 calculator. And I will give you like a heads up that I think some versions, like there's a TI-84 plus, and there's like a regular TI-84. Some versions don't have the inverse t function. And if you don't have the inverse t function, then you've got to use class calculator. And let me show you how right now, how to use the class calculator to find this. So let me, well, I'll start over again and I'll input everything for you. So first I went to stats, then I went to distance plots, and then I went to t distribution. It's wanting me to enter something, and it's a DOF, which means degrees of freedom, or it means the, actually, I apologize. Degrees of freedom is 1 less than your sample size. So they actually, degrees of freedom is usually 1 less than your sample size. So actually, if 22 is the sample size, then we want 21. Okay, so we input, and they even give us the distribution of what the t distribution actually looks like with degrees of freedom 21. So, and then I in that parenthesis, because that's all we need to tell it to know about the t distribution, is just the number of degrees of freedom. Then now I'm going to go to inverse. So I go to stats, I go to distant plot, I go to inverse CDF. And now I'm going to enter that area under the curve to the left, like I said, like the 1 minus 0.1. And there's my answer, the 1.323. And so let's just double check it. 1.323 is 1.323. That's exactly what we want. Yes. Right. So that is, oh, and I think I forgot to show you that too, like on the TI-84. Let me just double check. Okay. So you have to check on the TI-84 calculator whether they're asking for degrees. They'll say DF for degrees of freedom. If they ask for that, then it's n-1. But if they are, I can't remember whether TI-84 actually just asks for the number in your sample, or whether they ask for degrees of freedom. But if they're asking for degrees of freedom, then you want to put the 21. I think you would have gotten the answer right either way, but in this particular problem, but I think you actually want degrees of freedom and not the number in your sample. But they're so similar. All it is just 1 less than the degrees of freedom is just 1 less than the sample size. All right. I hope you found this very valuable. I know it's a really drawn out thing, but yeah, it's not that bad. One mistake that I feel like students make is when they're trying to find this T alpha over 2, they sometimes think that they're finding T sub 0.2. Let's find what that value is. And then let's take that value and divide it by 2, but we're not doing that, right? This is like we're doing this part first, and then we find the t value of once we have one single number as like a sub number of the t. Okay. All right. I hope you found this valuable. Have a great day. Let me know. Please message me if you have any questions. Okay. Bye.